Good morning, everyone, or afternoon or evening, whenever you happen to be watching this. I hope you're all still doing okay. I still miss you tons and tons. Let's get it today with our 12D notes, right? Last target of KC12, then we're just going to be doing a bunch of practice until we go back to school. Fingers crossed that we go back to school after spring break, right? This is the last target before your spring break. I hope you all have a lot of fun. Staying inside, but finding ways to have fun even though we're all kind of stuck at home. So 12D, we've got solve a system consisting of a line and a quadratic equation algebraically. Okay, so we've done systems of equations before, right, where we had two lines and we had to figure out, right, where they intersected. So now we're going to be doing the same thing, but this time they're not both going to be just linear lines. One of them is going to be quadratic and one of them is going to be linear. So we kind of have the two situations. So over here we have two solutions because they intersect at 2 points. We have one solution because you have your quadratic and your other line and they only intersect at 1 point. And then we have no solution, right, where you have your quadratic and then you have your line over here and they never intersect. So those are the three different options, right? So last time we had one solution and no solution. The other thing we had was infinite solutions, where your two lines were, right, your infinite solutions were where your two lines were right on top of each other. So that meant that they always crossed over each other. With this one, we don't have the option of infinite solutions unless both you had two quadratics and they were right on top of each other, but we don't have that in this case. So for numbers 1, 2, and 3, it wants us to figure out the number of solutions for the system. So we're just going to use our calculator and see what it looks like. So we're opened up here. So let's look at our first one. So you go to your home page, we want a graph. Okay, so I still have our first one pulled up here, right here. Let me retype it out so you guys can see how we do it. So we've got 5 plus x squared. Then you click enter, and then if you want to get another line, just double click on your screen, and then we have just a regular 5. So as you can see, right, you can just kind of pull and drag it around if you need to. This one has one solution, right, because we had a line looked like this and then our other line was just coming right down. Oh, let me undo that, make it look a little better. Oy. There we go, right, we have one solution. Right, then let's look at our next one, right? We can type it into our calculator. So I'm just going to click document, file, new document, and don't save the other one. And then click add graph. So we have 7 plus x squared is our first one. And then our second one, right, double click, and then we can get a new graph. And then our second one would be 16. So if we see, right, you have your quadratic and then your line, and as you can see we have 2 points here, right? So we had our quadratic and then our line kind of went straight through it, so this gives us 2 solutions. And then our last one, I'm going to click document, file, new document. I don't need to save the other one, and then add graph again. We have 5 minus x squared for this one. Click enter, and then we have, just double click on the screen to add another one, and then you have 2x plus 10. Alright, so as you can see, do these lines ever intersect? No, they don't, right? We have our quadratic and then we have our linear line over here, and as you can see, your two lines never touch. They never connect, intersect, so we're going to have no solutions on this one. So if we kind of want to draw a visual, we had our quadratic kind of like this, and then our linear line went like this. So this one is going to be no solution, right? Because your two lines never intersect. All right, so with this next one, it says give the ordered pairs that represent the solution to the system of equations graph below. So this time we're not just saying how many, right? It says give the ordered pairs. So we're actually writing out what the solutions would be, right? So here we go. Here's our line and our quadratic. So we have to actually give the ordered pairs for what each one would be. So if we look at this one, I know it's not really perfect, so we're going to have to, estimate it a little bit. So if we look over here, I'm just going to call this 1.5. Right, if we look at this one, it's kind of halfway in between 1 and 2. And then if we look at this way, I'm going to say it's 3.75. Oh my gosh, that doesn't look good at all. We said it was 1.5 and then 3.75 on the other one. So we kind of estimate it. Same thing with this one, right? We're going to kind of have to estimate it a little bit. So we look at the ordered pair, we look for the x first. So it's in between 0 and -1, so it's going to be -0.5 on this one. And then we kind of look, I'm going to say this is in between 1 and 2, so I'm going to say that this one is 1.5. Right, next one, and as you see with this one, right, you can only see that they intersect really at just this one point. So we're going to draw our point here, and then our ordered pair is going to be 2, 1. Oh my gosh. There we go. And that's a 2. 2, 1. All right, so it says, when solved graphically, determine the solutions of the following system of equations. So when it says determine the solutions, right, in our directions, determine the solutions, that means we have to actually give the ordered pairs. Right, depending on how many solutions you have. So it could just be one, it could be multiple, right? The other word we use for that is coordinates. So when it actually says determine the solutions, it doesn't say determine how many, it says determine what they actually are. So our first one is x squared minus 3x plus 7, and then x plus 4. So again, we can do this in our calculator. So our first one we have is x squared minus 3x and then plus 7. Perfect. And then we have y equals x plus 4. So double click, then our other one was it equals x plus 4. So we have our graph and we have our two, right, it says F2 and F1. So we need to actually figure out what our solutions are for this. So, I mean, we don't really know exactly what it is, so we can use our menu to help. So we can go down to Analyze Graph and then find the intersection. So it's going to give you this bar and it's going to ask you for the lower bound. So it depends on which one you're looking at. So if we're looking to find this intersection right here, we're going to do the lower bound and then the upper bound, right? So then it gives you that intersection is 1, 5. So there's our first one, right? And we can do it again. So Analyze Graph, intersection. Now we're going to give a lower bound, not all the way down here because we only want it to be for this point up here, so kind of somewhere in the middle, and then over here. Boom, there's our second intersection. So your calculator can actually find your solutions for you. So we had 1, 5 and 3, 7. All right, and then let's do our other one. So I'm going to go to Document, File, New Document. I don't want to save that one, and then back to Graph. So we have x squared plus 4x minus 1. Boom, there it is. And then you can just literally double click anywhere to get a new line, and then our other one is just a -1. All right, so we see here that we have, again, two solutions. So we're going to go to Menu, Analyze Graph, and then Intersection. So it depends on which one you want to find. So if we're going to find this one over here first, we're going to do the lower bound, so a little bit to the left of it, and then an upper bound would be a little bit to the right. So that gives you your first one. Do Menu, Analyze Graph, Intersection. We're going to do the other one, so a little bit to the left of the intersection and a little bit to the right of the intersection. And boom, we have our 2 points again. So -4, -1, and 0, -1. Alright, and then the last one I'm going to do in this video is this one, and then I guess I'm going to have to do another one with a part 2. So it says graph y equals x plus 1 on the coordinate plane below and determine the solutions. So it already has the quadratic on there for you. We have to graph this line. So, right, we can kind of put the one that's in front of the x, 4, is kind of invisible. So remember, this part is our slope, and then this is our y-intercept. So your y-intercept is 1, so we're going to graph that first. So we're going to go down here to a y-intercept of 1, right, and we're going to put a point there. And then, right, then we want to look at the slope. So our slope is 1. In order to find our rise and our run, we need to turn that into a fraction. So what we can always do is just put it over 1, because that doesn't change the value of our number, right? Anything divided by 1 is just itself. So we're going to turn that into a fraction of 1 over 1, right? And they're both positive. So we're going to go rise is up 1, and then run is right 1, because they're both positive. So that means from this y-intercept point, we're going to go, starting here, right, we're going to go up 1 and then to the right 1, and that's going to give us our next point. And then from here, we're going to go up 1 and to the right 1, and that's going to give us our next point. Then we're going to do it again. We're going to go up 1 and to the right 1. That's going to give us our next point. Right, now we see we actually have created both solutions, right? First solution is here because it crosses, second solution is here because it crosses, right? So if you want to go through and connect all your points, there you go. Right, so by doing that, we graphed our line with the quadratic that was already there, and then it asks us for the solution. So we have to actually give what these two ordered pairs are. So if we look at this one, right, it isn't any left or right, so your x is 0 and then your y is 1 because we went up 1. And then we look at this one over here, our x is here at 3, and then our y is over at 4. So our coordinate is 3, 4. So this has given us our two solutions. So we just write them as 0, 1 and 3, 4. Alright, the rest of the notes I'm going to have to do in a part 2 because it's going to cut off my filming. So I will see you guys in just a second. Bye!